Welcome back to the deep dive. Today, we are undertaking a pretty critical mission.
All right.
If you're out there prepping for the Salesforce Agentforce Specialist certification, this deep dive is really essential preparation.
Absolutely is.
We're going to be focusing on extracting the most vital knowledge you'll need around deployment strategies, environment governance, and, well, the often chaotic conflicts that pop up when different teams try to deploy changes.
And that's a problem that's only getting more complex as AI agents start to, get their hands on metadata.
Exactly.
So our objective today is to move beyond just simple definitions.
Mhm.
We need to really understand the architectural and the procedural implications of a robust application lifecycle management strategy.
Right.
We're pulling actionable insights from sources that cover everything from basic team coordination, the mechanics of CI or continuous integration, all the way to advanced environment strategies and, like you said, the new complexities that AI-assisted management brings.
And to ground this whole discussion, we're starting with a classic, and I mean agonizing, real-world problem.
The kind we see all the time.
It's the one that proves why you just can't skip robust governance. So let's look at this initial scenario. You've got a big enterprise on Salesforce, and they're split into two main development groups.
Okay.
You have the highly agile admin and low-code team on one side,
Yep.
and on the other, the dedicated developer and integration team.
The two classic camps.
So the low-code team, they're deploying small, frequent changes every month from their standard developer sandbox. Meanwhile, the developer team just finished this massive 6-month project,
Oof.
and it was all built and tested in a full sandbox, a sandbox that hadn't been refreshed since the project kicked off.
I think I see where this is going.
You probably do.
What happened next is just a textbook example of a deployment failure. Just total metadata mayhem.
A complete mess.
When that developer team finally deployed their huge project to production, several changes and configurations that the admin team had made over the last 5 months were just gone.
Reverted or completely overwritten.
Completely. And this wasn't just some technical setback, right? It immediately tanked user productivity. It required a multi-day effort to roll back and fix. And, well, naturally, it created a huge amount of conflict between the teams.
And the sources say the developer team then turned around and blamed the admins for not refreshing their full sandbox before the final push.
Which, of course, is not how that's supposed to work at all.
Not at all.
It just perfectly illustrates a critical failure of governance. When you have multiple streams of work hitting production without a unified, enforced strategy, especially using environments that are wildly out of sync with what's actually in production, the deployments become adversarial. You're finding these conflicts in production where they do the most damage to the business and to user trust.
And that developer sandbox, it was never meant for that kind of long-term project.
No, it was designed for isolation, not for integrating these massive month-long projects that absolutely need production parity for any kind of meaningful final testing.
That sets the stage perfectly. You need structure to prevent this from becoming a zero-sum game.
You do.
So that essential structure, it really starts with governance. And this isn't just about, drawing an org chart. It's about defining the rules of engagement, the whole decision-making process. So what are the foundational elements of a robust Salesforce governance framework according to what the source material lays out?
Well, the Salesforce documentation points to 4 core tenets that really structure an effective governance framework. They help organizations manage the platform efficiently.
Okay, what's the first one?
The first is the Center of Excellence, or COE. And it's important to note, this isn't a physical place. It's the process. It's the mechanism you use to manage the governance itself.
Right, it's the how.
Exactly. Second, you've got change management. And this covers every single step, from gathering requirements all the way to moving tested code from a dev environment into production.
And the other two tenets, they cover the structure and the quality standards, right?
You got it. The third is the org strategy. This defines the fundamental structure of your production orgs. Are you single org, multi-org, some kind of hybrid? And then finally, you have design standards.
Which are crucial on a multi-tenant platform like Salesforce.
Absolutely crucial. They standardize your integration patterns, your security protocols, coding standards, testing approaches, all to ensure long-term stability.
Okay, let's focus on the COE for a minute, the engine of this whole framework. Who should actually be in this center of excellence, and what are their primary measurable goals?
The COE absolutely must be a cross-functional team. It can't just live in IT.
So it's not just for the techies.
No, not at all. It has to include IT architects, platform owners, Salesforce admins, and this is the most important part key business stakeholders and leaders.
Why is that business involvement so critical?
Because without it, IT risks just prioritizing technical needs over actual business value. The goals of this team are broad. They need to enable the business to innovate quickly, manage all the compliance requirements, things like data residency, security, and drive velocity by systematically prioritizing what gets built.
So the COE is really about delivering success.
Ultimately, yes, by sharing best practices and making sure skills are aligned across different departments.
So the COE prevents that chaotic, uncoordinated deployment we saw in our opening story by giving everyone a single source of truth for procedures and priorities.
That's the idea.
So how does the COE document its mission and keep all these different teams aligned?
It starts by defining the North Star. Some call it the governance charter.
Okay.
This is the foundational document. It spells out the key business goals, the high-level strategies to get there, and the specific reasons Salesforce was chosen in the first place.
And from a project management view, what's its main purpose?
Its primary purpose is to prioritize requirements that lead quickly to business value, and, just as crucially, to prevent scope expansion. Scope creep.
The project killer.
The project killer. The charter ensures that when conflicts come up, say, between two business units demanding different features, the decision aligns with that strategic North Star. It keeps all efforts linked directly to the most important business KPIs.
That makes the COE sound less like a bureaucratic hurdle and more like a necessary steering committee.
That's a great way to put it.
Now let's get into the specifics. What are the actual functional roles you need to make this governance program work day to day?
The sources highlight 3 roles as being essential. First up is the business analyst, or BA.
Okay.
This person defines the project's entire business requirement roadmap. They translate what the business needs into technical requirements. The BA is so important for finding commonality across different business units, looking at the existing Salesforce roadmap to spot any overlap or dependencies.
So they have to really understand the business architecture.
Deeply. To engage effectively with the business owners.
So the B is the functional bridge, making sure requirements are clear, documented, and aligned with value before they even get to the development pipeline.
Correct.
But what happens when the BA wants to push a feature out quickly, but the technical team is worried about, long-term stability or enterprise security? Who sets those technical guardrails?
Oh, that tension. That's managed by the second critical role.
Yeah?
The enterprise architect, or EA.
Okay.
The EA defines the company's best practices and technical standards. We're talking integration patterns, security architecture, the whole software development lifecycle process, coding standards.
They're the enforcer.
They are the enforcer, yeah.
Yeah.
They make sure all development sticks to corporate IT policies. The enterprise architect is that vital link between the Salesforce teams and the broader IT organization, making sure Salesforce development doesn't create technical debt or, violate enterprise-wide rules.
That seems like a potential point of friction, though. You have the BA pushing for business speed and the EA pushing for enterprise compliance. How does the COE resolve that?
Well, that tension is exactly why the COE exists as a cross-functional body and not, a dictatorship.
Right.
The resolution often comes back to that governance charter, the North Star. If the BA's quick deployment plan violates a mandatory security standard set by the EA's position usually wins.
But the work still has to get done.
It does. So the BA then has to work with the EA to find a compliant solution that still delivers value. Maybe it's an alternative integration method or a phased rollout. The COE provides the documented framework for that negotiation. It turns it from a personal conflict into a procedural decision.
That clarifies the decision-making loop. Okay, and finally, who handles the execution, the scheduling, the whole logistical side of this operation?
That falls to the Project Management Office, or PMO. The PMO defines the overall delivery schedule, manages the roadmap, and figures out the approach for end-user training.
And they own communication, right?
Crucially, yes. The PMO owns the communication strategy, making sure the project teams and the wider user community are in sync about go-lives, outages, or necessary training. They also often act as the catalyst for adopting new, more efficient delivery models like Scrum or DevOps, and they enforce that critical feedback loop between the business and IT.
And that choice of delivery model, agile versus waterfall, that has a huge impact on how change is managed and deployed. How should an architect compare them in a Salesforce context?
Well, waterfall is defined by its sequential, linear nature.
Step by step.
Exactly. Requirements are gathered, then design is finished, then build, then test, and finally deploy. This method is really best when your requirements are super well understood up front, the scope isn't going to change, and predictability is the main goal.
So like in highly regulated industries.
Perfect example. Industries that require extensive upfront documentation and sign-off.
And Agile, like Scrum, it sort of embraces the chaos, the uncertainty you often find in these big platform projects.
It does. Agile emphasizes short, iterative development cycles. It incorporates continuous feedback loops every few weeks.
So it's much better for Salesforce projects where things change fast.
Usually, yes. It's far better suited for fast-changing or complex Salesforce projects that need rapid innovation and flexibility as business needs evolve. But, in the real world, the source material notes that a purely agile or purely waterfall approach is actually pretty rare for large Salesforce implementations.
Right, you see a blend?
You see a blend. Sometimes it's jokingly called water scrumfall, where you have significant upfront planning, that's the waterfall part, followed by iterative builds, which is the Scrum element.
So when you're making an architectural recommendation, the key is to assess the constraints of the scenario.
Exactly.
You'd recommend Agile if the goal is rapid innovation and flexibility, and Waterfall if you need strict compliance and predictability from the very start.
That assessment is absolutely vital. You have to focus on the risk profile and the certainty of the requirements. If the business unit needs quick results and they're willing to iterate, lean toward Agile. If compliance means every document has to be signed in triplicate before a single line of code gets written, then some waterfall elements are just unavoidable.
Let's pivot to the political and procedural component of this, the business IT partnership and change management. If we're enforcing a clear separation of duties, who ultimately owns what?
Best practice dictates a separation here to enforce reliability and accountability. The business must own and prioritize the business backlog.
And that's so important.
It's vital because typically the business is asking for 3 to 4 times more features than IT can realistically deliver. IT should never be in the position of making core prioritization decisions about business value.
So the business decides what gets built and when based on value, but IT decides how it gets built and how it gets deployed safely.
Exactly. IT should manage the technical development and the promotion of those enhancements into production. This includes adopting mature application lifecycle management tooling and processes, source control, continuous integration, automated testing, and enforcing that ITIL principle of separating development duties from operational deployment duties.
And that separation ensures that speed doesn't compromise stability.
That's the goal. It mitigates the risk that speed, driven by business demand, compromises the stability of the platform.
Okay, moving from that strategic framework to the environment itself, the org strategy is the next big decision. Should an organization go with a single Salesforce org or multiple orgs? And what are the complex factors that drive that choice?
This choice really shapes everything that follows. A single org centralizes all business units onto one platform.
The 360-degree view.
That's the benefit. You get consistency, standardization, much easier global reporting. You get that 360-degree view of the customer. The risk, though, is considerable. As it grows, it can become incredibly complex. Sometimes people call it a monolith or a big ball of mud.
And you can hit platform limits.
You can eventually strain Salesforce platform limits, which leads to potential performance issues.
And the multi-org approach.
Multi-org involves deploying multiple production orgs. This is often chosen to give autonomy to distinct business units, maybe one org for EMEA and one for North America, or to comply with different regulatory requirements, like data residency rules that mandate separate instances.
So you avoid the scalability limits.
You do, but you introduce massive challenges in integration and coordination. The configurations of these orgs can diverge, and they can do it quickly, leading to feature inconsistency across the entire enterprise.
That divergence risk is the major drawback. So if an organization chooses multi-org for business reasons, how does the architecture mitigate that risk of the orgs getting out of sync?
The sources really stress that your architectural design has to align with your chosen strategy. In a multi-org model, you have to use a modular approach.
What does that mean in practice?
It means modularizing common functionality things like address validation, user management, core custom objects into packages that can be deployed simultaneously across all the orgs. This ensures a baseline of consistency.
And if you don't do that?
If you fail to do that, you end up relying heavily on complex, often expensive integration layers like MuleSoft or custom ETL just to keep data in sync. And that adds significant cost and complexity that you have to budget for.
Okay, let's zoom in on the sandbox architecture within that model. The sandbox strategy is the tactical foundation of any repeatable release process. What are the key sandbox types and, more importantly, their distinct purposes and limitations?
We really have to understand the four primary types and their refresh limits. We start with the core dev environments, developer sandboxes and developer pro sandboxes.
These are for isolated work.
Exactly. Designed for isolated development and unit testing. They have minimal storage, but they have the fastest refresh rate. You can refresh them daily. They're meant to be disposable and source-driven.
And Developer Pro is just bigger.
Basically. Developer Pro just offers more storage for slightly larger feature development, but it has the same daily refresh frequency.
Then we move up to environments that need realistic data for testing integration and user processes.
Next is the partial copy sandbox. These are used for integration testing and often for initial, smaller-scale user acceptance testing, or UAT. They contain a sample of production data, which requires a sandbox template to define exactly what data gets copied over.
What's the main constraint there?
Their major operational constraint is the refresh frequency. You can only refresh a partial copy sandbox every 5 days. That limit makes them totally unsuitable for continuous development work.
And finally, the largest, most restricted type. The one that caused the big failure in our opening scenario.
That's the full sandbox. This environment is reserved for only the most comprehensive use cases. UAT, performance and load testing, and staging environments that have to perfectly mirror production right before a go live.
It's an exact replica.
An exact replica of your production environment, all data and all metadata. And because provisioning this is so resource-heavy and time-consuming, the refresh limit is extremely restrictive. 29 days.
That 29-day limit is a time bomb. If you look back at our opening story, the dev team worked for 6 months in a full sandbox without refreshing. What is the guaranteed consequence of ignoring that limit for so long?
The consequence is, well, it's guaranteed metadata divergence. If a full sandbox isn't refreshed for 6 months, it's effectively an independent production environment from 6 months ago.
A time capsule.
A time capsule, yeah. Any changes, hot fixes, or admin tweaks that went into the actual production org over those 180 days are just absent from that full sandbox. By the time that development team deploys, they are guaranteed to overwrite or revert hundreds of changes because their source environment was not reflective of the production state they were targeting.
So that 29-day limit really forces your hand.
It forces you to use the full sandbox sparingly and only for very specific final testing purposes, never for long-term development.
That makes the standard release phase flow highly structured. Can you just summarize that progression for us?
Yeah, the flow is progressive. Isolated feature development happens in a dev sandbox. Once that's complete, it gets merged into a shared integration sandbox, which is often a shared partial copy, for team testing and conflict resolution.
Okay.
Then it moves to the final UAT sandbox, typically a full copy for full regression testing for business sign-off, before finally deploying to production.
This flow gets complicated by parallel development and, urgent issues. How do architects manage concurrent work streams?
The strategy is simple, but it has to be enforced. You mandate separate developer sandboxes and separate feature branches for parallel projects. Project A and Project B must develop in isolated environments until their merge points.
And that prevents them from stepping on each other's toes.
It prevents one project's unfinalized features from accidentally destabilizing another project's testing phase.
And what about the emergency hotfix, the most disruptive kind of change?
For hotfixes, you need a dedicated, accelerated pipeline. This involves using a specific source control branch, often branched directly from the production branch, and a dedicated sandbox to completely isolate the emergency fix.
You test it, deploy it quickly, and
then the absolute non-negotiable step is back promotion. The hotfix changes must be immediately merged back into the main development line, the integration or develop branch.
Why is that so critical?
To ensure that when the next scheduled release goes out, the fix is included and not accidentally overwritten. Failure to back promote means that bug will return, potentially within days.
Finally, let's talk about the inevitable. Salesforce's 3 seasonal releases a year. This platform upgrade is forced on us. How does an architect mitigate the risk of disruption from these upgrades?
You have to utilize the sandbox preview environment functionality. Salesforce upgrades a predetermined subset of sandboxes weeks before the actual production rollout.
So you get a heads up.
You get a heads up. The essential mitigation strategy is ensuring you have at least one full or partial sandbox on that preview instance, often called the preview org, to run a full suite of regression tests and assess the impact of the new features. If you skip this, you risk discovering broken mission-critical functionality only after your production org has already been upgraded.
Okay, the environment strategy provides the architecture. Now let's focus on the mechanisms. Continuous integration and continuous delivery. Let's start with a precise definition of continuous integration, or CI.
Continuous integration is a software development practice where team members integrate their work very frequently, often multiple times a day, into a common branch of a version control repository.
And the key is automation.
The key is automation. Each integration has to be verified by an automated build and test run to detect integration errors instantly. The whole goal is to make integration a non-event, to ensure your source code repository is always in a deployable state.
This practice seems tailor-made for high-velocity environments, but what are the specific challenges of implementing CI in the Salesforce ecosystem?
Oh, the challenges are significant. First, the required paradigm shift is huge. Many teams are used to working in their sandbox for weeks before they merge. CI mandates breaking complex tasks into very small, manageable chunks for frequent integration.
And there are technical hurdles, too.
There are. The platform's complexity adds friction. It can be hard to get reliable automated regression testing because of governor limits, and you have inconsistent testing frameworks across different types of metadata, testing a flow versus testing Apex code.
But the rewards outweigh the challenges. So let's map out the typical logical flow of a CI pipeline.
The process is always automated. It kicks off with a continuous integration trigger, which is usually when a developer commits or pushes code to the version control repository.
Okay.
This immediately triggers a quick build step, which runs basic validation tests. Then the validated package gets deployed to a shared DEV environment or maybe a Scratch org.
And this stage has to include concurrency control, right?
Yes, concurrency control is crucial here. It's a mechanism to make sure two developers aren't deploying conflicting or dependent changes at the same time.
And the final step.
Finally, the system runs a build and publish step, which results in a deployable artifact in artifact repository. This artifact is a tested, reliable package that's ready for the next stage of the pipeline.
So CI ensures the code is integrated and verified constantly. Continuous delivery, or CD, builds on that foundation. How should we define CD and what are its core principles?
Continuous delivery is the ability to get changes of all types, whether it's Apex code, configuration metadata, or even reference data into production, safely and quickly in a sustainable, repeatable way. Is the logical successor to CI.
And what are those foundational principles an architect needs to know?
The first principle is to build quality in. This means you identify and fix bugs immediately, ideally before they're even committed to version control. You want to avoid relying on time-consuming, error-prone manual testing. If your quality gates aren't automated, you can't really achieve CD.
Okay, and the second principle?
The second core principle is to work in small batches. This isn't just to prevent feature branches from diverging so much that merging becomes impossible. It also drastically cuts down on the cognitive load and context switching for a developer when a merge conflict does happen. It lets them fix conflicts way faster. Small, frequent merges are always safer than these big, monolithic quarterly releases.
To make this high-frequency automated process possible, the version control repository, usually Git, has to be the center of the universe.
Absolutely.
Why must source control be the single source of truth, and what branching strategy supports CI/CD best?
Source control has to hold all your production metadata. This is what makes every change trackable, auditable, and repeatable. It's the fundamental component that allows multiple developers to work in parallel without tripping over each other.
And the branching strategy manages that parallel work.
It does. We use a branching strategy for that. Typically, a new feature will start on a dedicated feature branch. When development is ready, it gets merged into a central develop integration branch for group testing. The final, vetted, production-ready code lives on the main master branch.
What about hotfixes?
Any hotfixes need a temporary, isolated hotfix branch, which gets deployed and then immediately back-promoted into that main development line.
This version control requirement brings us to selecting deployment tools. We know change sets are native, but why do organizations pretty much always need to move beyond them for serious CI/CD?
Change sets are great for simple tasks. They're accessible to admins, they're UI-driven, they're native, but their limitations are severe.
Like what?
Well, for starters, they only work between connected orgs, like from a sandbox to production. They require manual dependency management, so if you miss a field dependency, the whole deployment fails. They lack any built-in rollback functionality. They can't handle destructive changes like deleting a custom field, and they're just too tedious and time-consuming for large volumes of metadata.
And they're useless for multi-org.
Useless. You can't use them for multi-org deployments across separate production instances.
So when complexity or scale demands automation, we have to move to the APIs.
Exactly. The metadata API, which you access with tools like the ANT migration tool or the SFDX command line interface, is the automation workhorse. It's scriptable and highly efficient for large deployments.
What are its key strengths?
Its strengths are critical. It supports destructive changes. It can deploy to any org as long as you have credentials. And it's the key integration point for CI/CD automation servers like Jenkins or GitHub Actions. It delivers the repeatability and scale you need for a mature ALM process.
And what about the third-party DevOps tools? Are they just fancy wrappers around the metadata API, or do they offer something unique?
Well, tools like Capado, Gearset, or AutoRevit are indeed built on the metadata API, but they solve the usability and complexity issues that the native CLI tools present.
How so?
They provide graphical interfaces, they automatically detect and manage component dependencies, and they offer critical features like automated scheduling, rollback functionality, and backup capabilities. They really fill the gap by providing enterprise-grade compliance and audit controls. Implementing one of these tools is often the solution when organizations need to solve those very specific coordination and override issues that come from having multiple development teams.
Okay, we've established that scalable CI/CD relies on the metadata API and external tools. The architecture then has to evolve to use packages for modular development. Let's clearly lay out the different types of Salesforce packages, starting with the one that's least suitable for long-term release management.
That would definitely be the unmanaged package. This is really meant for a one-off distribution, like sharing a sample application or a template.
And the key thing is that it's not upgradable.
It is not upgradable. That's the defining characteristic. Once the package is installed, the components become independent in the target org. The original developer has no control over them and no ability to push updates. Because they lack version control and upgrade paths, they're generally avoided for any kind of internal, long-term enterprise release management.
Next up, the managed package. A lot of people assume this is only for AppExchange ISVs, but is there an internal enterprise use case?
Managed packages are primarily for ISVs, yeah. They're defined by having a unique namespace and supporting controlled push-based upgrades. Their components are generally locked down for IP protection.
But for internal use?
For internal use, you might see them if a very large organization manages a core application that needs to be deployed consistently across many separate global production orgs. This lets the core IT team control and upgrade that central component reliably across multiple disconnected instances.
Which brings us to the gold standard for enterprise ALM, unlocked packages. How are they different from managed packages, and why are they preferred for internal DevOps?
Unlocked packages were specifically designed to solve this problem of internal enterprise release management. Like managed packages, they are upgradable and they support versioning, but they're flexible. They don't impose IP protection or lock down the components.
So an admin can still make changes in the target org?
Exactly. An admin can still tweak a component if necessary in the target org without breaking the whole upgrade path. They're ideal for modularizing a massive org's metadata. You could create a separate package for your Sales Cloud customizations, another for service features, and a third for core utility components.
And they fit right into the modern process.
They require Salesforce DX and version control, which makes them the superior fit for modern CI builds.
Let's clarify a technical distinction between the two core APIs involved in development, because this can be a tripping point. The metadata API versus the tooling API, what's the functional difference from a deployment architect's perspective?
This is a really key technical nuance. Think of the APIs like infrastructure. The metadata API is the primary robust mechanism for mass transit.
For moving big things.
Exactly. It moves large chunks of metadata, entire packages, custom objects, hundreds of fields, all your code between orgs. It's used for all major deployments and migrations, and crucially, deploying to production requires running all necessary Apex tests through this API.
So it handles the bulk movement and the compliance check, and the tooling API.
The tooling API is the precision instrument. It's designed for much finer-grained operations, primarily for building developer tools, things like IDEs, debuggers, or static code analysis scanners.
So what would a developer use it for?
A developer would use the tooling API for tasks like running a single Apex test method for immediate feedback, or retrieving a specific class's symbol table, or getting code coverage data for just one component.
So the big takeaway.
The critical takeaway is that the tooling API is not typically used to deploy full metadata packages to production. It just lacks the necessary robustness and bulk processing capabilities for that mission-critical task.
Deploying code and config via API is only part of the release. A full strategy needs to handle the task that automation can't touch. So let's outline the mandatory pre- and post-deployment tasks. What essential steps have to happen before the package is moved?
Pre-deployment tasks are all about risk mitigation and business continuity.
Okay.
These include communicating a change freeze to the organization, disabling any scheduled jobs or integrations that might interfere with the new code like a batch job that might run halfway through the deployment, and especially before a major release, exporting a robust data backup.
So you're just making sure the environment is stable and ready.
Exactly. Ready to accept the change without any interruptions.
And what are the crucial steps immediately after a successful deployment?
Post-deployment tasks are necessary because some components deploy as inactive or they need data linkage. Key examples would be you have to activate newly deployed flows or process builder processes. They deploy inactive by default for safety.
Right.
You also have to manually assign new profiles or permission sets to users to grant them access to the new features. And if the deployed app needs configurable data to work, you have to load that reference data.
That reference data point leads to a crucial architectural recommendation. We often see teams confused about how to manage configuration data that's needed for an app to run but isn't strictly schema metadata. Should they be using custom settings or custom metadata types?
Best practice strongly favors custom metadata types.
Why is that?
The reason is operational efficiency. Custom settings data is not migrated via the metadata API. It has to be loaded separately as data, which introduces a manual step that's prone to error and often gets missed in deployment checklists.
But custom metadata types are different.
In contrast, custom metadata type records are deployable as metadata. They can be included directly in your unlocked package, versioned in source control right alongside the code, and managed completely through the CI/CD pipeline. It just significantly streamlines the whole release process.
Quality assurance is the final structural safeguard. We established earlier that the version control repository is the source of truth, not the developer sandbox. This source-driven approach is paramount for quality.
And that repetition is necessary. Org-based development is just. It's chaotic. For a mature organization, the quality checks have to be automated and built right into the deployment process.
What are the main methods for enforcing quality checks before code is even allowed to merge into the main integration branch?
The quality checks are layered. First, you have mandatory code reviews, which are typically done via pull requests. That ensures peer oversight and knowledge sharing. Second, you employ static code analysis tools like PMD or SonarCube to automatically scan Apex code for anti-patterns,
Like SOQL in a loop.
like running SOQL inside a loop, which just wastes governor limits, and also for security vulnerabilities like CRU DFLS violations. And third, you have to have strict compliance with Salesforce's mandatory testing requirements.
Okay, let's nail down the core testing requirement for production deployments.
The mandatory technical requirement is that 75% Apex code coverage must be achieved across all the Apex code in the org, and all Apex tests must pass for the deployment to succeed in production.
But 75% is the floor, not the ceiling.
Exactly. Hitting 75% is the minimum. Good testing has to be robust. It needs to cover your positive cases, the expected behavior, your negative cases, so handling bad data or exceptions, permission-based cases to make sure different profiles see what they should, and crucially, bulk operations.
Testing with 100 or 200 records.
At least, to make sure the code is properly bulkified and won't hit those dreaded governor limits.
That robustness feeds into the overall unified test data strategy. What makes test data both representative and secure?
Test data has to be representative, which means its structure and volume have to accurately mirror real production scenarios. If your production environment has accounts with tens of thousands of history records, your full sandbox for performance testing has to reflect that scale.
And at the same time, secure.
At the same time, that data has to be secure to maintain compliance with regulations like GDPR or RUPA. This requires data masking or anonymization replacing sensitive PII, or personally identifiable information, with fake, non-sensitive data in sandboxes, especially if full and partial copies that are shared across teams.
And how should developers manage data creation for Apex unit tests specifically?
The standard best practice is to use a test data factory. This is a design pattern within Apex unit tests, where you create the specific, known test records you need for that test class at runtime.
And that makes the tests independent.
It ensures that tests are entirely independent of any existing org data, which guarantees they'll run reliably regardless of when the sandbox was refreshed or what configuration changes other teams have deployed.
Moving into operations, what are the negative implications when admins or developers bypass governance and make changes directly in production? And what's the necessary mitigation strategy?
The implication is immediate metadata drift. The production org diverges from the source of truth in version control.
So the next deployment is at risk.
The next planned version deployment is then at high risk of overwriting that untracked production change, breaking functionality that the business is now relying on.
And the mitigation.
It requires immediate action. You use SFTX or metadata comparison tools to retrieve that change from production and back promote it into the source control repository and the corresponding sandboxes. It's the only way to prevent it from being lost in the next scheduled release cycle.
And when you're dealing with a multi-org environment, say 5 different production orgs around the world, how do architects prevent divergence across all those live systems?
Centralization and modularity are key. The recommendation is to enforce the use of modular packaging, specifically unlocked packages, to deploy common components simultaneously to all 5 production orgs in tandem. This maintains consistency across the enterprise for any shared functionality, which is far more manageable and repeatable than trying to deploy 5 separate raw metadata packages and just hoping they all land correctly.
Now let's turn to the crucial focus area for the Agentforce Specialist, the emerging role of AI agents in deployment. The Agentforce components themselves, we're talking Gen AI Planner, Gen AI Function, Gen AI Plugin, and Gen AI Prompt Template, they aren't static metadata. They're highly complex, behavior-oriented agents.
Right, and this shifts the fundamental paradigm. Traditional ALM tooling was built to move static files. These new Agentforce components represent dynamic behavioral logic, and they demand specialized governance. The promise of these autonomous AI agents is to fundamentally automate and optimize the DevOps process by introducing profound new capabilities.
Let's detail those promised autonomous capabilities, focusing on how they solve pain points we've already discussed, like metadata drift.
First, there is autonomous tracking. The agent continuously monitors your defined metadata stores and automatically reports on any differences that metadata drift among your environments. It just eliminates the need for manual comparisons and complex hand-to-hand documentation.
So it's constantly scanning for those sneaky production changes.
Exactly. Second, dynamic scheduling. The agent autonomously determines the optimal deployment windows based on historical data. It looks at past success rates, failure rates, deployment durations.
And that's all to minimize business impact.
It's all designed to minimize business impact and maximize change velocity by intelligently timing the deployment.
What about safety and recovery? Automated rollback seems like a massive improvement over manual fixes.
That leads right to automated rollback. The agent versions and checkpoints each deployment. If the post-deployment tests fail or a monitoring threshold is breached, it can instantly roll back the metadata to a previous verified point in time. And then you have self-healing deployments. If the agent encounters deployment errors, like a missing dependency or a minor permission conflict, it attempts known remediation patterns it's learned from past successes, like field deletion or permissions reconciliation, rather than just failing immediately and requiring a human to intervene.
A self-healing deployment. That level of automation is a true game changer. What does the agent offer for compliance and testing efficiency?
For compliance, the regulatory compliance audit capability is powerful. The agent meticulously records every detail, the component, the user, the time, the result, to a secure, tamper-proof audit object. This gives you a clean, easily traceable history for compliance standards like SOX or GDPR.
And for testing?
On the testing side, the agent can dynamically select test suites. So instead of spending hours running the entire regression suite, the agent intelligently selects and runs only the impactful Apex test classes necessary based on the changed metadata coverage, which significantly boosts release speed.
Given these incredibly powerful capabilities, we have to address the essential limitations and risks of offloading mission-critical deployment tasks to these agents. This is where organizations have to be most vigilant.
Oh, there are significant architectural and governance challenges here. First is the risk of human oversight gaps. Because the agent is autonomous, it can run complex deployments without adequate human verification. This increases the possibility of promoting incorrect or unintended changes to production that a human reviewer might have caught. The speed can compromise the scrutiny.
And the agent, being a complex piece of AI, seems like it would make root cause analysis harder when something does go wrong.
That is the second major risk. Debugging challenges. When a deployment fails, tracing the root cause can be exceptionally challenging because the agent's decision-making logic is often hidden under layers of abstraction. He can act like a black box, which can severely delay problem resolution and recovery time, especially if the agent has tried some self-healing steps that obfuscate the original error.
And what about the conflict with those traditional governance processes we talked about in the beginning?
That's the governance conflict risk. Companies that rely on strict change management processes, like ITIL, may find the agent inadvertently creating compliance issues. If the agent implements a change without the required manual approval tickets being closed, or if its automated audit history doesn't neatly align with the mandatory procedural steps, it can bypass those human-in-the-loop requirements and create regulatory exposure.
Are there technical nuances that an AI agent, which is operating purely on metadata, might miss?
Yes, the agent is often blind to implicit dependencies, not visible in AI. Highly complex implicit dependencies, things like the intricacies of role hierarchies, sharing settings, or complex user access rules, are often not explicitly attached to the metadata the agent is moving.
So it doesn't see the full picture.
It doesn't. If the agent doesn't see these implicit rules, it might deploy changes that, for instance, accidentally revoke field access for an entire department in production, an outcome it was never programmed to anticipate.
And finally, there's the human element, the fear of change.
The final limitation is resistance within the organization. Employees, release managers, senior admins, they may be reluctant to rely on AI-driven automation because of valid concerns about job security, the perceived opacity of the solution, or just a sense of losing control over a process that used to require their expertise. Organizations have to proactively address these human factors during adoption, focusing on upskilling roles rather than eliminating them.
The sources do outline a very compelling case for this shift, though, suggesting savings of several hours per deployment and a significant reduction in failure rates.
Oh, the paradigm is clearly shifting from manual orchestration to intelligent orchestration.
This deep dive has covered the necessary architecture, governance, and mechanics you need to manage a complex Salesforce environment, all the way up to the advanced world of Agentforce deployment. For your specialist certification prep, let's quickly recap the most critical takeaways.
Okay. First, remember that governance and the COE provide the structure. Know the four tenets and make sure you can articulate that mandatory separation of duties. Business owns the backlog. IT owns the reliable release management process.
Right. And second, master your environment strategy. Understand the strict use cases for developer, partial, and full sandboxes, and how that 29-day full sandbox refresh limit makes it totally unsuitable for long-term development.
Third, be fluent in deployment tools and packaging. Know why unlocked packages are the ideal modular choice for enterprise ALM, and make sure you grasp the difference between the metadata API for deployment and the tooling API for developer utilities.
And always recommend custom metadata types for configurable reference data.
Always. And finally, the future. Agentforce. Memorize the 75% code coverage rule, but focus your strategic study on the advanced capabilities of the autonomous agent dynamic scheduling, automated rollback, and self-healing deployments.
And you have to balance that knowledge with the immediate risks they present.
Critically, particularly the challenges that come with debugging abstract agent logic and the risk of implicit dependency failure or governance gaps.
The entire deployment architecture is evolving from human execution, supervised by tools, to machine execution, supervised by humans.
That's the perfect summary.
Yeah.
And if these AI agents promise massive time savings and fully automated compliance audit trails, it raises a really interesting question for the future of ALM.
Which is?
How does the role of the human release manager evolve? They go from being the primary technical executor of the deployment script to becoming a high-level governor, whose job is solely to verify the agent's logic and overall design before hitting that final automated deploy button. The governance role becomes elevated, demanding strategic oversight rather than just tactical implementation.
A truly fascinating evolution in the age of Agentforce. Thank you for joining us on this deep dive.
My pleasure.
We'll catch you next time.